All right, hello. This is practice problem 1.2 from Solidworks CSWA, and this is also going to be in the playlist Solidworks CSWA practice problems. And if you want to follow along with the practice problem as you watch the video, you can find the link in the description that will link you to the official Solidworks practice problem database. And so let's get modeling. First, you're going to want to set the units, metric, mmjs. Then you're going to click sketch and go to the front plane. Now, this problem really gave me a lot of trouble the first time I did it, but the trick is you need to draw the entire geometry first and then constrain it with dimensions. Because if you only draw part of it, you don't have enough dimensions to constrain. So we will eyeball it to our best of our ability. This will have to be perpendicular line. This line will be parallel. This is the insertion. Perpendicular, perpendicular. This one is a vertical line. We'll have to constrain that, and then a horizontal line. Okay. And then we will draw the staircase in the back. Looks like this. And now that we have the base geometry, we will start dimensioning. This makes it a lot easier. Let's get the angled line first. Angle of 65 degrees. Then distance between this line and this line will be 8. The distance between the bottom line and the first step is 16. And then the distance from second step to first step to second step will be 18. And their respective lengths for the first step will be 24. Second step will be 16. Yes, okay. The distance of this gap will be 5. This dimension will be 15. This is where the cylindrical extrusions will be sketched on top of its face. And you know it's 15 from section AA. And then the distance between the top edge and the bottom of the insertion is 36. But of course, we have to make these two lines collinear, so they move along the same dimension. There you go. And then obviously the total height of the entire geometry, it's not this line, don't let that trick you. The total height is the highest point, so it'll be this point to the bottom edge, which will be 58. And then the total length of the entire part is 78. And now you have a fully defined sketch. So now we will extrude it in 2 parts. The first extrusion will be 28. Is that 28? Yes, 28. The first extrusion will be 28. And we will only be extruding this part, the main part, the main profile. And now we will extrude the staircase by selecting the same sketch. This time, the staircase is only extruded by 18. Select contours, only the staircase. Select OK. This part's flat. And now, this is the last step. We're going to create a sketch on this face. And to make our life a little easier, we're going to use the mirror tool so we can keep the positions symmetric. So let's make the center line coincident with the midpoint. Let's draw a circle. Actually, let's draw another center line to constrain it. Center line along the midpoint of the of this horizontal line. And we'll draw a circle here. And we will set its diameter to, let's see, 6 in diameter. And then we will set its distance. Let me see if I'm reading this properly. Yes. Da da da. Yes. Yes, yes. Okay. We will set the distance from center point to this edge as being 7.5. Oh, actually, we don't need to do this because we already centered it with the center points. So I guess this is kind of a fast way of doing it. But you can dimension the center point, distance from center point to this side edge as being 7. And we can use mirror entities. My computer is about to explode, but it's okay. So select entities to mirror, select a circle, mirror about this center line. Bada bing. It's an easy way to create symmetric relations. And we will extrude this by 6. I believe that is all. Now let's check the answer. We got 70,039 cubic millimeters, which is the correct answer, as can be seen by the answer key right here. Hope you learned something, and I'll see you in the next video.